Ok, bắt đầu. Good afternoon, respected teacher and friends. We are team including Phan Khánh Huyền, Thị My, and Nguyễn Thị Lan Nhi. Today we are honored to present our project, self-projection using linear regression. The main content of our presentation will include, firstly, the reason for choosing this project, secondly, practical application of the project in real life, thirdly, technology used in the project, next, the entire process of the software operation, finally, additional information and conclusion. We sincerely look for what to your attention and feedback so that we can further improve our project. Now let us start with the first section, the reason for choosing this project. Our goal was to address common challenges businesses face, such as optimizing advertising budgets, managing inventory effectively, and predicting customer demand to support better decision making. Through this project, we aim to provide data-driven solutions that are practical and impactful. Additionally, this project offers an excellent opportunity for us to gain hands-on experience with data analysis, machine learning, and Python libraries like Pandas, Scikit-learn, and Matplotlib. They are essential tools for anyone aspiring to work in a data-focused role. Moreover, working with real-world datasets allows us to tackle common challenges like missing data and outliers, enabling us to build and evaluate regression model effectively. The skill we develop here can also be applied to other domains such as housing price prediction or financial forecasting. Lastly, this project is a significant addition to our portfolio, showcasing relevant skills for roles like data analyst or business intelligence analyst. Now that we understand why this project were important, let us look at how it can apply in real life scenario. Um, let us move on to its practical application in real life. Self-prediction has far-reaching applications that benefit business across industry. Firstly, self-focusing. By accurately predicting future sales, businesses can plan their marketing and operational strategy more effectively. Secondly, advertising budgets or optimization. This project helps determine the best allocation of advertising spend, ensuring maximum return on investment. Um, Thirdly, inventory optimization. Predicting demand enables business to maintain optimal stock levels, reducing waste, and preventing stock count. Finally, strategic business planning. By providing data-driven insights, the model supports informed decision-making for long-term growth and success. The application demonstrates how self-reason can transform business operations from to day-to-day management to long-term planning. Now let's explore the technology we use to make this project a reality.
The technology is integrates consist data processing libraries, machine learning libraries, visualization libraries, graphical user interface, and supporting libraries. The data processing libraries includes pandas and lumpies. Pandas is data frame operation for easy data selection and slicing, built-in method for handling missing values and applying statistical techniques like probability calculation. And the lumpy is creating custom arrays for advanced calculation. Efficient computation of those descriptive statistic line means variance and correlation. Random data generation for testing purpose. uh, the machine learning libraries divide into three sections: linear regression, MSE, and R square. The purpose of linear regression is fit a linear regression model for prediction, as the coefficients are most multi-dimensional feature provides coefficient and intercept change model using ordinary least square. The purpose of MSE is to measure average square prediction errors. The coefficient which is penalize larger errors more heavily have assessed prediction accuracies. The purpose of R-squared evaluates variance explained by model. The coefficient provides a value between 0 and 1. Closer to 1 indicates a better fit. In the Matplotlib encodes a visualizer prediction. It enlarges across predict cells, accept module accuracy, and improves user experience with visual insights. The coefficient are scatter plots, highlight change, and duration reference lines, so perfect prediction for easy comparison. Customization includes title, labels, and legend for clarity. Tinker integration in passports in improvise via finger canvas Tcast. We use Tinker's guides for model interaction. It provides a user-friendly interface to interact with the machine learning module. The key features are data loading, intuitive dialog for loading, CS refines model training, pattern checker training with success or error messages, matrix display, post-up showing performance matrix, examples MSE and R squares through visualization generates and display prediction plots within the application. And the part spotting libraries, we use Matplotlib, backends, because it integrates Matplotlib plots into the Tinker guides. The key visuals are embed scatter plots, reference lines, and legend into the application, enable scheme list and direct visualization within the lines.
And now we will discuss the entire process of software operation. The first step is data loading and cleaning. We start with data import, where the user they can upload a CSV file through the UI. The software uses the pandas to efficiently read and display the dataset. Following this, data cleaning comes into play. The software automatically removes the rows with missing values to maintain data quality and ensure the accurate model training. So once our data is clean, we move on to selecting the right features and preparing the data for training. In this step two, we have the feature selection. It means involves extracting the most relevant features such as advertising cost, inventory, and potential customer, while setting a sales as our target variable. We then use the train test split to divide the dataset into training that take up 60% and testing subsets that take up 40%. Leverage, Leveraging the train test split from Scikit-learn. Now that our data is prepared, we are ready to train our model and evaluate its performance. So in this step 3, model training and evaluation, we use the train model function to feed a linear regression model to the training data. When the user clicks on the train model button, the train model will the train model method will be executed. And evaluation follows where metrics like mean square error and R-squared score are calculated to assess how well the models perform on unseen test data. The model coefficients and intercept are also extracted for further analysis. With the model trained and evaluated, let's see how we visualize the result. The step 4 is the visualization and result. The software will generate a scatter plot that compares the actual and predicted sales. A reference like is included for easy visual assessment of prediction accuracy. And about the display matrix, evaluation results such as MSE or R-square are presented in a user-friendly pop-up window. This will have the user to quickly interpret how well the model is performing. As you can see here, is the output. This is the output of matrix display, and this is for the prediction plot. Integrating this functionality smoothly into the user interface make more interactive and intuitive expensive. So in step 5 here, we have the UI integration. We have some like the UI features like interactive buttons that make loading data, training model, and viewing metrics simple and efficient. Like you can see here, this is a UI for our program. And a data display window pops up to show the loaded data set, providing a user a chance to inspect the data before model training. Next here we have the visual representation that includes the button to generate a scatter plot. A button here like show prediction plot in the UI that I have mentioned before. We have the button to generate the scatter plot that compare actual and predicted sales. So finally, let's consider how we can explain and improve this project in the future. There are some additional information here. The first aspect is scalability. Like this software, it can be expanded to support more advanced models like random forest or gradient boosting and enhanced visualizations such as time series plots or heat map. And about the applications in real world scenarios, this project will help the businesses to forecast sales, optimize the budget allocation, and make data driven decisions. Next here we have the limitation. Currently, at this time, the model just can handle only a linear relationship, and its performance heavily relies on the data quality and quantity. And the last one is the future enhancement. Like we are thinking of some potential improvements, include integrating the databases for managing larger data sets and implementing automated parameter tuning. So in summary, this project it demonstrates how data-driven approaches can effectively support sales predictions, combining straightforward models with an intuitive user interface, while there are still areas to improve and refine. So I believe this work will lay a solid foundation for future advancement, like incorporating more sophisticated models and enhanced data integration. So now I'll demo the code for you. So the first thing you need to do is run the main file here. Just wait a minute. So this is the GUI for our sales prediction program. The first thing you need to do is to load the data here. You click on the load data button, and which allows you to load your file here. And now it will a window will pops up and show you the loaded data set. So in here you will have the chance to inspect the data before model training, like you can see here. So next you click on the train model button and it will show us the prompt, a message box that notify us that the model have been trained successfully. So you click on OK. Then you then is the show matrix button. When you click on it, it will show us some like some evaluation, like evaluation result, like MSE and R square. They are presented in this pop-up window, as well as we also have the intercept and coefficient as well. So click on OK. And the last one is the show prediction plot. So when you click on that button, it will show us it will generate a scatter plot that compares the actual and the predicted sales. So as you can see here, I mentioned before in our slide. So a reference like here is also included for easy visual assessment of prediction accuracy. So that's all for our demo. Thank you so much for listening.